Hi. Okay, so welcome to the second part of this review and preview. So for our preview, we're going to be looking at what we're going to be doing next year in 2022 once you guys are back in the building. So we're going to be learning about stratigraphy, and stratigraphy simply means the arrangement of geologic events in a sequential order, which means you see different geologic events like the layering of different rocks or different events, and then you are trying to do a forensic of what happened first and what happened second and what happened last. So putting these geologic events in sequence is what is called stratigraphy. Scientists and geologists use different principles in doing this. So we're going to go through three of such principles, which is what we're going to be looking at the first week after you guys are back in the building. Okay, so the first principle is the principle of superpositioning. Okay, so we'll take it one at a time. So I want to start with the principle of superpositioning, and what that simply means is oldest rock will always be at the bottom, and then the youngest rock will always be at the top. Okay, remember the analogy we used in class one time? So if you came back from school and you take off your clothes and you drop it in your laundry bag, and then on Tuesday you come back and then you take off your clothes and you drop it in. By the time you drop it each day, we can tell that this is what you wore on Monday, because what you wore on Monday will be all the way at the bottom. So that becomes the oldest clothes that you've used for the week. All right, while your Friday outfit will be the one that will be on top. So whatever is on top is the most recent, is the youngest. Then whatever is at the bottom is the earliest and the oldest. So the principle of superposition simply means whatever is old will be on top and whatever is young will happen on top. All right, so whatever is old will be at the bottom and whatever is younger will be on top. So the youngest will be on top, the oldest will be at the bottom. Simple and straightforward. The next law is the law of original horizontality, which means that the rocks or the layers of sedimentary rocks will be formed in horizontal manner, all right, by gravitational force. Just like you see in this diagram here, they are laid down horizontally. And then so once you see a sedimentary rock that is not horizontal and it has been folded or it has been pushed or deformed or tilted, the folding, the tilting, and whatever it is happened later after it was deposited horizontally. Might not be so clear, but I'll throw more light on it. But simply put, everything is laid down horizontally before folding or tilting would happen. So when you look at this, you see that they are folded a little bit. All right, it means they were first of all laid down horizontally first, which is original horizontality. Originally, they were horizontal before they folded. Yeah, then the last law that we're going to look at is the law of cross-cutting relationship. Okay, which states that anything that is cutting through another thing is the youngest. For instance, if you look at these, you have layer 1, layer 2, layer 3, layer 5. Then if you see this structure is an igneous intrusion, something is intruding and cutting through. So it cuts through layer 1 and cuts through layer 2 and cuts through layer 3. For you to cut through 1, 2, 3, 1, 2, 3 must have been there before you can cut it. Yeah? Good. So it's just like saying before you can slice the bread has to be on the table first before you can slice through. So before you can cut through anything, that thing has to be in existence first, or the thing has to have arrived on the scene already before you can go through it. Otherwise, what would you go through? So if 4 is going through 1, then 1 must have been there before 4. If 4 is going through 2, 2 must have been there before 4 came to cut through it. If 4 is cutting through 3, then 3 must have been there first and older before 4 can come and cut through. However, you look at 5, 4 did not cut through 5, which means it was after 4 arrived that 5 was made on top. So 5 is on top everything else, which makes 5 the youngest. Okay, so in terms of age, we have 1 is the oldest, 2 is the next online, 3 is the next in line, and 4 is the next older, and 5 is the youngest. Okay, so that is that with the principle of cross-cutting relationship. So those are the 3 laws that we're going to be looking at and using in this video. The law of superposition: whatever is oldest is at the bottom, whatever is youngest is on top. The law of original horizontality: all the layers are laid down horizontally before anything can come and fold them or teach them or fold them. Then the law of cross-cutting: whatever is cutting through is younger than whatever is being cut through. I'm just going to throw a little more light on each of them, and then we go do some practice question. The law of superpositioning, right here again, oldest rock and sediment must be laid down before younger ones can be laid or piled on top. Good. So that's what it simply means. So oldest will be at the bottom and youngest will be on top. That's the law of superpositioning. Just to throw more light on it, so if you have this kind of diagram, mostly in your regent question, it simply means that the guy that is at the bottom will be the oldest, and the guy that is all the way on top will be the youngest. Once again, superposition: oldest rock on the bottom, youngest rock on top. Next is the law of original horizontality. So if you look at the diagram on top, you see that all the rock layers were laid down perfectly in horizontal manner. They were not disturbed. Then something came and then made them to start looking wavy or squiggly or bent or folded. Okay, so which means horizontally they were laid down originally in a horizontal manner before the folding. And what would cause them to fold? That's a good question. What would usually cause them to fold is tectonic plates or tectonic movement or continental drift. When the continents are moving, they move with enormous force that they can squeeze places in different parts of the earth. So if this was laid down horizontally, as continental thrust happens, it can cause them to fold. It can cause rock layers to fold upward or fold downward. All right, so continental plate and continental movement causes horizontal rocks to start folding. Okay, so most times in the regions you get asked a lot, what caused the folding? You should be able to say, oh, plate movement or continental drift or cross-star movement. That is what causes it. So that is it with the law of original horizontality. Rocks are originally laid down horizontally. And lastly, cross-cutting. Okay, so once you have somebody or something cutting through different layers, whatever is cutting through must be the youngest, because for this guy to cut through this and cut through every other thing, then all this other stuff must have been there already, and that is why it's cutting through them. Okay, so this is basically an igneous intrusion most times. So if you look at the diagram to the right, you have the oldest at the bottom, and then you have the older one on top, and then the youngest is the one cutting through. Make sense? Yep. Let's see if we have any other one, and we'll wrap it up here. Still basically the same thing. You still have the oldest rock at the bottom, and then the youngest or younger will be all the way at the top. Then whatever is cutting through will be the new youngest guy, because this and that and that and that must have been in existence for it to cut through all of them. Simple as ABC. So putting it all together, this is how it looks. Superposition: youngest rock at the oldest rock at the bottom, youngest on top. Original horizontality: all rocks are laid down horizontally before they are bent, tilted, or folded. Cross-cutting: whatever is cutting must be younger than whatever is being cut through. And that's it. Cool. So let's move to some practice question, and I'll let you guys rock and roll with your exit ticket. All right, I would work question 1, 2, 3, and 4. Then I'll let you guys do 5 to 10 for your exit ticket, or 5 to 9 for your exit ticket. Yeah, 5, 6, 7, 8, 9. Yeah, I'll do 1 to 4. Cool. So question 1. So we have this beautiful art crop here. You can read all the instruction there. So the question is, what is the possible age of rock E? We're going to zoom in a little bit. So what is the possible age of rock E? So rock E here, we see that it is the igneous intrusion. So you see this oldest guy at the bottom here. That should be the oldest. This should be the next older guy. This should be the next older. And then you see rock E cutting through all of them. So rock E must be younger than D, younger than C, and younger than B. So rock E has to be something younger than 24 million years ago, or 24 million years old. However, A is on top E, which means E must be older than A, because right now A seems to be the youngest guy in the block. It's the most recent guy happening right now because it's on top E. So that would be the youngest. So E must be something more than 1.6 but less than 24. So let's look at our option. A, 1.5 million years old. No, that is less. So it cannot be younger than A. So that is not our option. So that is out. B, 12 million years old. 12 million years is less than 24. Good. And more than 1.6. Yeah, that's our answer. Possibly our answer. Let's run through the rest. 28 is more than 24. No, that's a no-go area. D, 40 million years ago is older than 24. That is a no-go area. So our correct answer is B. You see, that's how I applied the law of superpositioning and cross-cutting together in one question. Question number 2. Which of these events occurred most recently at this location? So when you look at this location right here, which event happened most recently? Option A says the deposition of layer A. So I see layer A right here. A cannot be the most recent guy because after layer A, you see this new layer formed on top. So that must be more younger and more recent. So definitely option A is out. Igneous intrusion. So I see the igneous intrusion cutting through everything. So it's possibly the most recent guy, but you see this fourth XY? That XY also cuts through the igneous intrusion. So this XY looks like something that is younger than the igneous intrusion itself because it's cutting the igneous intrusion. So igneous intrusion must be older than XY. Okay, so I think the correct answer should be XY. I can't find because XY is cutting through everything, even the igneous intrusion, and cutting through the layer on top as well. So yeah, the fourth thing definitely will be the answer there. And what can cause faulting? Earthquakes. When the earth is vibrating and tectonic plates are moving, it can cause things to break. It can cause multiple rock layers to break. So it's things like faulting or earthquakes that can affect or create XY, which is a cutting relationship. We'll go into that deeply more when we are in the building. Let's move to rock. Question number 3. Which rock unit is youngest in age? So we have A, B, C, D. D would be the oldest, going by the law of superposition, and then C would be the next older guy, and then B is an igneous intrusion. All right, we see that right here. It's an igneous intrusion, so it's intruding through D and C, which means it's younger than D and C. However, layer A is the guy that is on top everything. So the guy that is on top every other thing must be the youngest and the most recent guy in the block. So our answer would be A. Let's do number 4, and then that will be the last one I will do, and I'll let you guys do the rest for your exit ticket. Question number 4 says, evidence of tectonic activity in this cross section is provided by the folding and the tilting of rock layers. Yeah, that seems like it. Remember I told you what could cause rocks that were laid down horizontally, going by the law of original horizontality, what would cause them to fold? What would cause them to fold is tectonic plates. When continents are moving and drifting and forcing and squeezing themselves. So that could cause folding. So folding and tilting of the rock layers shows that tectonic activity occurred in this region. Option B says faulting. There's no fault here. Fault is like a crack. Okay, for example, this is a fault. This guy labeled Earth here is a fault. I don't see any crack here. Igneous intrusion into rock layers. I don't see any igneous intrusion either. Collision of crustal plate boundaries in the rock layer. Collision of crustal plate boundary in the rock layers. It does sound like D, but I still remain with option A. Yeah. Okay, that's it. I'll let you guys rock and roll with the rest, and see you all in 2022. Bye.